In this video, we shall talk about polynomials. Polynomials, by general definition, is the sum of ak power x minus k. Let me rewrite this again. Sum of k is equals to 0 of ak power x power k. Okay, so this means that you take the first k term from ak0, which is a power 0, and you put x power k, which is x power 0 in the first term. And then it goes from a1 to x power 1, a2 power x power 2, all the way till an x power n. So what we have seen certain forms of polynomials before. We know that the quadratic function here is a polynomial because it has the form of ax squared plus bx1 plus cx power 0. In fact, if I were to just delete this, I can rewrite this as a power 2 plus a power a of 1 plus a of 0. This in fact is a polynomial. Okay, the cubic function also ax squared plus ax cubed plus bx squared plus cx power 1 and dx power 0 is a polynomial. Okay, and there are many ways to actually solve for a polynomial. Okay, just take for example the quadratic function. Okay, you have three ways. We've covered this before, which is by factorization or completing the square or by the quadratic formula, which is x equals to minus b plus minus square root b squared minus 4ac over 2a. Okay, these are three ways to actually solve for it. But for high levels of polynomials, it becomes more difficult to actually solve for it. One of the ways is to use guessing, meaning you put a specific number, sub in a specific number into the polynomial, to the function, and you have for example, in this case of quadratic formula, we have a power 1 cube plus b1 square plus c1 plus d. Okay, and say all of this, let's say all of this is equals to 0, then the substituted value here is a root of the polynomial. Okay, you won't be tested on this, but there are many other ways to actually solve for this. Firstly, you could also use the cubic formula, or actually in high levels you have a root theorem. Okay, a polynomial can also be represented by this, where px is equals to the dividend times the quotient plus a remainder. Okay, so this is the polynomial, this is the dividend divisor or dividend, and this is the quotient, finally the remainder. Okay, this is especially important because you can use this to actually find the roots of a polynomial. How? Okay, so let's take a very long polynomial. Let's see, ax cubed plus bx squared plus cx plus d. Okay, a cubic function. One of the ways you can find this is, let's say you want to find a root. Okay, a root that says that this is x. Okay, x plus, let's see, minus e is a root of this function. Okay, so we know that I can represent this as g f x is given by x minus e, which is a divisor, okay, times, I want to find what is the q of x here. Okay, But because this is a root, right? So we know that there is no remainder. Okay? Should there, okay, so there will be no remainder. Okay? So you can do this, but how do you find this? Simple, by long division. Okay? So you have ex cubed plus bx squared plus cx plus d, you long divide it. Okay? And whatever you have up here, right, the answer here is equals to qx, q of x. Alright, but say x of e is not a root. What then? Okay, so if it's not a root, right, the g of x, okay, the long division of g of x minus e, okay, which is essentially just this, okay, which is essentially just this, okay, will give you something like this. So you know that the top of bit will be q of x, okay, and once you complete the long division, you have a remainder. This is your remainder. Hence, in this case, if x is not a root, then you have g of x equals to x minus e of q of x times q of x plus r of x, where r of x is the remainder of the long division. Okay? Some interesting notes about the cubic function is that good to remember is that you have a sum of cubes is given by a cubed plus b cubed. This is equals to a plus b a square minus ab plus b square. And the difference of cubes is given by a cubed minus b cubed. So a minus b a square plus ab plus b square. Okay? So this is some good to remember items. Okay? Finally, the use of it is explicitly used in partial fractions. Okay? Partial fractions has three forms. It's either a distinct linear function, okay, where the fraction has two specific ax plus b, cx plus d. Okay, this is given by a of ax plus b plus b of cx plus d. Okay, this is the first form. Secondly, you have repeated linear functions where px plus q by ax plus b squared is given by a over ax plus b plus b over ax plus b squared. And lastly, you have a quadratic factor. Means that you cannot factorize it further. Okay, so px plus q, x plus r. Okay, if ax plus b, qx, no, sorry, x squared plus c squared. Okay, and this is equals to a over ax plus b plus bx plus c over x squared plus c squared. Okay, this is the three basic forms. Okay, the most important thing that you want to know about this, you want to remember, is that the top, the numerator has to be less than the denominator. Okay, so if the numerator has x squared, the bottom one needs to have x cubed. Okay, if let's say the numerator has more than equals to the denominator, okay, you need to do long division. Okay, if not, just do partial fractions. Okay, partial fractions is especially useful when you want to break down your fractions into easier formats, and this will be very useful, especially in the topics when it comes to differentiation and integration. Okay, finally, to solve for, let's take for the first case. To solve for this, just multiply the one side to the other. So px plus q over ex plus b cx plus d is equals to a of ex plus b plus b cx plus d. Okay, so what you do is you multiply these together, and then you can bring this across. So in the end, what you get is actually this form. You solve for this. Okay, so solve for a and b, and you have this. Okay, how do you solve for that? Just substitute x, a specific value of x inside here, such that this becomes 0 or this becomes 0. Okay, and that's all for polynomials and partial fractions.